Welcome to our business track of the Data Science Salon YouTube channel. For this presentation, we have Rhonda Textor, Head of Data Science at TrueFit, talking about product recommendations for fashion. She shares their approach to extracting, representing, and modelizing size and shape in order to learn the connection between the shopper's physical characteristics and product size and fit. By leveraging this information, they can make recommendations that are more relevant to shoppers, leading to a better shopping experience overall and a fewer size-related product returns. Enjoy!
Hi, my name is Rhonda Textor. I'm the head of data science at a company called TrueFit, which I'm happy to talk about more during this talk. And I'm going to be talking about making fashion recommendations that fit. It's very important in the fashion space. So first I want to start by talking a little bit about who TrueFit is and what we do, and hopefully pointing out some places that you may have already seen us online, even if you didn't know that much about TrueFit. So TrueFit is a company a data and fashion company that's mission is to help real people find clothes and shoes that they'll love and keep. And what's important to us in this mission statement is that we help real people. So personalization and making recommendations to actual people, whether they're fashionistas or whether they're just people who are looking for clothes to wear. We are all about the clothes and shoes, items that have a fit component and that have a fashion component. And we want to help people not just purchase clothing, but we want these to be items of clothing that they'll love, that they'll keep, and that hopefully will keep them coming back to the platform and to the retailers on a long-term basis. So you've hopefully seen TrueFit in various places online. These are some screenshots from some of the retailers that we are integrated with online, and just wanted to show some examples. We have some style recommendations that are shown here on the left side, and we have our most popular tool that's been around for the longest time is our confidence engine, which is a tool to help people figure out what size to buy when they're shopping online. This works for items of clothing, including tops, bottoms, and dresses. It works for footwear, and it also works for kids' clothing. And so we have a capability that enables you to create a profile for someone else, say your own child, someone else's child that you're buying a gift for. And so this helps you figure out what size to buy in brands that you're perhaps unfamiliar with. As you might imagine, given the state of the world, people are coming online to shop more than they used to and are seeing the value of having help finding the right size to buy in greater numbers. How do we do this? We have a data set called the Fashion Genome. This is what we believe is the world's largest fashion data set that is all-encompassing, that includes billions of transaction data on the right-hand side. This comes from our retail partners and clients. But what's really important about this is that we've annotated and added a lot of value to this data set by really understanding the individual items through our partnerships with brands and through some of our hand labeling and hand tagging of items. And then we also, through our online experience that requires registration, we've gotten to know well over 100 million shoppers and what their preferences are. To go into a little more detail, this is the type of information that we have for individual products. Things like brand and price, a lot of size information, which, as you might imagine, is important for making things like fit recommendations, and then a lot of information that we're able to pull out from descriptions and in some cases hand label, in some cases automate. On the shopper side, we have information that shoppers provide us as part of the registration process. We can also pull in things like purchase history from stores that are part of our network. We solicit information about favorite brands and sizes as part of the registration process. And we think that this is really important for the real person part of our mission. So, for example, if you see that someone buys this particular pair of pants, this particular pair of jeans, you might make an assumption about them. But we find that usually people are much more interesting and nuanced than one particular item of clothing. And so in this case, we see that this shopper tends to buy things at a discount, which is kind of an interesting characteristic. And finally, all of this transaction data coupled with these attributes and these shopper characteristics allows us to learn interesting relationships between shoppers and the products that they buy. In this particular example is where we learn the relationship between sleeve length preferences and size of clothes. And I don't think any of us will be too shocked to see that on the upper end of the size range, there's more of a preference for short sleeves over sleeveless. And so this is just one example of something we can learn from this data. So that's a bit about who we are at TrueFit. What I want to talk about is our philosophy to helping people find clothes and shoes online through making recommendations. Again, I lead the data science team, and so we're really thinking about how we leverage this data and machine learning algorithms and recommender systems in order to surface more relevant items to shoppers to make their shopping trip a little less painful. And then I'm going to go through an example in some more depth to show some technology that we've developed as part of this suite of algorithms to help people find similar styles or perform things akin to visual search. Then I want to talk about kind of our bread and butter, so to speak, at TrueFit, which is making recommendations that fit and how big a component that is in the shopping journey. And then I'll wrap up and take questions. So to start, I wanted to start with a bit of a mathematical formulation for this particular crowd, for something that we all kind of intuitively know, all of us who have shopped online or have really searched for anything online. And that is kind of putting a framework together that describes why this problem is so difficult. And I'm sure we've all had that experience where we're looking for something, just browsing online, and found that most of the items that we were seeing didn't really resonate. And then we quickly gave up and went about our business doing something else. And one of the reasons for this is because the sheer number of things available online is really huge. And so it can be difficult to find what you're looking for. There's a lot of decision fatigue involved. And so we see here that the probability of finding something relevant is proportional to the number of items that are relevant to you over the total number of items in a catalog. And what we're going to see is that we see both really large sizes of catalogs. So even for, say, a single brand store, we might see that there are thousands of items available for sale. And so that can be, clearly we aren't in a typical shopping session. We're not going to look at thousands of items. We're only going to see a small fraction of that. But then what we're going to see also is that as we move to bigger and bigger stores, like not only does that catalog size increase, but the variety also increases. And there are good reasons for this. So one of the advantages of, say, a bigger store that has more variety is that you are more likely to find something that resonates. So take, for example, some of the issues with single brand stores that if they have something that resonates, maybe there's a high likelihood that they have lots of items that resonate. So some single brand stores, for example, are centered around a particular size type. So think about men's big and tall. If you're a big and tall man, then there are a lot of items in that particular catalog that could be appropriate for you. But if you're not a big and tall man, then the probability of finding something at that store is going to be 0 because nothing resonates. With the multi-brand stores, they can offer a lot more brands, a lot more size types, a lot more different price points, which means that it's more likely that they have something for you, but it also means that it's starting to become harder to find that. As we move along this axis, we see that, say, with marketplaces like eBay, with a lot of the marketplaces that offer used goods for sale, with things like Google Shopping, Amazon, certainly all the data that we have in the TrueFit genome, we're starting to see catalog sizes that are well over the tens and hundreds of thousands into the millions. So we have even more variety, but that denominator in our probability has gotten even bigger. And on the extreme side, we as consumers technically have access to the internet. We can look across different marketplaces and across different stores. And this just makes the scale of all of the items available just really enormous and makes it very difficult to find things because of the growth in that denominator in the probability term. On top of that, I alluded to this earlier, we don't have infinite time as shoppers. We have other things to do. We are looking for something to hold our attention. In TrueFit data that we examined this year, we see that typically, on average, an online shopper will view about 5 items in one particular shopping session before the end of that session. And so thinking in terms of like statistics and probability, you have a low probability event, which is that you're trying to draw from a small number of relevant items in this enormous catalog, and you also have a small number of chances to get that right. And so this makes recommending items for online shopping a really difficult problem. On top of that, because this is fashion, there's also, these are items that people are shopping in order to wear. And there's a size and a fit component that's really, really important. So here's some evidence to speak to the importance of that as many as 50% of items that are returned that are purchased online are returned for size and fit reasons. We don't see return reason codes, so we look at data in some different ways. One of the things that we can measure is what percentage of online orders involve this concept that we call size sampling. So that's when someone buys multiple sizes of the same item, usually because they're uncertain about the size and they want to try that on at home. We see that this behavior often occurs 5 to 10% of the time when online shopping. And this is very costly for retailers and also for the environment, and also provides some pain points to the shopper who is engaging in this behavior. One of the reasons it's so costly is that not only do the items that don't fit, say in this case, one of the 2 items that didn't work get returned, but sometimes both of the items get returned because neither one has a good fit or because the item just didn't work out for some particular reason. And so this means that from a recommendation point of view, we have about 5 chances, that's on average. With a lot of shoppers, we have 1 chance to put something relevant in front of them. And then on top of that, even if it resonates at the time of purchase, we want to make sure that we're making the best possible recommendation, and it's most likely that the item will actually fit, so that we don't see that costly return on the other side. So I want to talk a little bit about relevance and what that means and how we're going to address that through recommendations. So we think about shopping trips and the purpose of shopping trips kind of lying on the spectrum that is between browsing and searching. And so on the browsing side, these are use cases where I'm not looking for anything in particular. I'm open to inspiration. Maybe I've been motivated because I'm bored or because there's a big sale going on. And then on the other side, the shopper has something very specific that they're looking for. Like, say, I just ripped my favorite jeans and I need to replace them by another pair of very similar, the exact same pair of jeans. Additionally, we have this axis that describes relevance in terms of who the shopper is, and we call this personalization. In this case, even if the shopper is looking for something specific, say jeans, it's not enough to just show the shopper jeans. You also have to take into account who the shopper is. So some people are really looking at, for example, price and really looking not to spend above a certain amount. And so if you show a shopper all jeans at expensive price points, that's not going to resonate, and they're more likely to exit out of that shopping session being frustrated and feeling that they've wasted their time. We certainly wouldn't want to just show everyone cheap jeans, because we also see a lot of shoppers who have preferences on the other side of the spectrum. And so we could think about people inherently having price preferences, having fit characteristics, having style preferences. There are many preferences that fit on this personalization axis. And it's really by combining the two that we have the best chance of surfacing relevant items for people who are shopping online. And so as we move to the right of the intent axis and move up on the personalization axis, essentially what we're doing is we're taking these enormous catalogs and we're driving down the size that we're drawing from, so that we're more and more likely to show shoppers items that have some relevance to them. And I want to walk through a quick cartoon example. Very simple and intuitive. But in this case, here I am on the bottom left-hand corner, and I don't know anything about the shopper. I don't know their intent. And so I have my full catalog of jeans and dresses here. So first, the shopper tells me something about what he or she's looking for, in this case, jeans. And so now I've been able to significantly reduce the catalog size, in this case by half. In the typical case, jeans might be a very small fraction or a reasonable size fraction of the total number of items offered. Furthermore, if I also know something about this shopper, that her typical size is in a plus size range, well, then it makes sense to really highlight and filter the items that are available in her size. And so here by looking at both personalization and intent, we're able to significantly decrease the total number of items available that we would show this particular shopper, which is increasing the likelihood that we're going to show something relevant. So now I want to move through a couple examples of algorithms that we put together based on our genome data set in order to achieve this. And so first I want to talk about this intent specificity in an algorithm that we've created to help shoppers find similar styles. So one of the underpinnings of our similar style algorithm is a computer vision pre-trained neural network. And just at a very high level, the reason that we would use this, or how this works, is that we could take a neural network that's been trained. In our case, we're using ResNet. And this neural network is trained on many, many different images on the task of identifying objects within an image. And this is a general neural network. It's not necessarily trained on fashion data. There are fashion items that are part of this data set, but there are also other items like cars and animals and houses. And what's very useful here is that it's taking this entire image and it's representing it as a vector of numbers. And when you take that vector of numbers, you can then compare different vectors and do simple operations like, say, Euclidean distance or cosine similarity to actually see which vectors are closer and farther from each other. If we look on the right side, this is a visualization using a technology called TensorBoard that enables us to visualize where items are in this space. And in this vector space, we're able to see that similar items are clustering together and less similar items are further apart in this space. And so this is how we're using neural networks to capture similarity between images that contain fashion items, which gives us a proxy for how similar these items are. However, one of the problems with this approach is that an algorithm, especially a traditional notion of similarity or distance that we use in machine learning, does not necessarily match with a human concept of similarity. And there are a few reasons for this. One is that similarity judgments are often asymmetric. And so we might say that a girl runs like a cheetah, but it doesn't make as much sense to say that that cheetah runs like a girl. Second, we don't necessarily weight all features the same way. So by default, a lot of the similarity measures that we use in machine learning have equal weight of feature importance. But we, for example, might care more that shared characteristics about shared characteristics than non-shared. And we might care more about some characteristics than others, especially thinking about what makes an item of clothing similar. We might care more about color than the fact that one item has a button and the other item has a zipper as a closure type. And so in order to understand this better and to build this component into our algorithm, we conducted a user study. And the way that we set up this study is that we gave the participants an image of an item that was out of stock, and we forced them to make a choice between two alternatives. And the way that we set this up is that many of these alternatives, like the ones pictured in this slide, wouldn't exactly match the characteristics of the query item. They would vary in one important respect. And so in this case, the dress on the left is about the same length, but it does not have sleeves. The dress on the right is a little bit longer, but it has the same sleeve length. And so when you're forcing someone to choose between the left or the right, you're basically asking, do you think it's more important that this matches on sleeve length or that this matches on overall dress length? And by conducting this trial many times over many people, we were able to learn essentially an ordering of which attributes matter most, at least for dress similarity. In the order that we found was that length was the most important, followed by color, pattern, and sleeve length, and then some other attributes. And so we were able to take this distance measure that we learned, including the feature importance, and build that into an attribute-based similarity based on the attributes of these items. We can then combine that with a different algorithm that's based on the computer vision in order to ultimately get the best of both worlds, where we're taking into account things like dress length that are the most important that might not come through as much in computer vision, while also leveraging computer vision, which is really good at picking out color and pattern. Second, I want to talk about our confidence engine, which is the component that makes recommendations that fit. And so using the past example, that's one of the tools that we offer that can help someone shop for something specific. Now, once they find what they're looking for, how do we make sure it's relevant to them and that they're more likely to keep the item? So one way to approach this problem, and in fact how a lot of people in this space approach this problem, is to learn something about height and weight and the relationship to the size that someone ultimately buys. And we use height and weight as one of the factors in our recommendation algorithm, but it's not the major factor. And one of the reasons is that is not the most predictive signal. So if we see this vertical line for BMI, we see that for the same BMI, someone could reasonably fall into many different dress sizes in the US, and so this certainly holds in other countries. But second, we find that it's important not just to understand the physical characteristics of someone, but also to understand how they like their clothes to fit in their historic preferences. And so the approach that we take to modeling fit preferences is to take this profile data that we have on shoppers and learn, both about their physical dimensions, but also about the size, the brands and the sizes of clothes that they've worn before, so that we can actually extract the mathematical model of how people want their clothes to fit at various points. We also have a mathematical representation along multiple dimensions of clothes in what are their fit dimensions. One of the important processes that has to happen is to take this size string, so in this case 00 through 12, and understand how that fits on a numeric scale. This is one of the hardest problems we solve. This could be the subject of a whole talk. It involves some automation and also involves a substantial operational process with human analysts. to map all these different size strings and variants across not just the US, but many different countries, including Europe and countries in Asia, and understand how they're all fit on this line relative to each other. Once we have all of this data represented in this common normalized space, what we can then do is learn from our billions of transactional data, the relationship between consumer fit preferences and the garment fit attributes. And so because each person's a little different, and because brands are very different across brands and even within brand and certainly across different locations, it's necessary to first map all of these into some common mathematical space, which then gives us the benefit of being able to use a rather large data set to learn this particular relationship. Once we learn this relationship, we can match those preferences to what we think is the best fitting size available for a particular garment that the shopper is interested in. And so here's one particular example. This is, again, our production fit engine that's available at a lot of stores online. And so we see these two different actual true fit shoppers have entered in the same height, weight, and BMI, but their brand and their size, their favorite brand and size that they've told us about are actually really different and translate into very different fit preferences. And so in this case, we recommend an 8 to one shopper and a 12 to another shopper, which more closely matches the brand that they've entered into their closet. So bringing this all together, how do these things work together? Just a reminder that, hey, if this shopper is looking for jeans, well, that's one of the attributes we have. We can highlight, hey, these are the jeans available. If, say, the shopper identifies that pair of jeans as interesting, we can then offer this navigation path using the stylistically similar capability that shows some similar jeans, some stylistically similar jeans that are dark in color and about the same length and that have the skinny silhouette. On top of that, because this is fashion and we care about fit, we want to make sure that the shopper gets recommended items that fit her. If we know that she's in the plus range, then we know which of these items are available in that size range, and we're able to recommend something that's relevant to her. And even more than that, we're able to figure out which size in these two different pairs of jeans would be the best fit for her, thereby helping her find something that's relevant, but also minimize the likelihood that she's going to have to return something because it doesn't fit. So thank you for paying attention. Thank you to DSS Elevate for the opportunity to speak to you all on this. I want to wrap up by just reminding everyone that as you've all experienced, shopping online can feel a bit like trying to find that proverbial needle in the haystack. That's because online catalogs are huge. At a minimum, there are thousands of items, but many of them are tens of thousands or even hundreds of thousands or more items, especially for these big marketplaces. And the proportion of items that's relevant to you is probably very small. Fashion shopping is even more challenging because in addition to finding something that fits in your price point and looks good, it also has to fit on you. And we believe that algorithms and data are the way to address this problem by learning from data and using that data to provide tools that enable a shopper to pre-filter content for both intent and personalization, which really reduces this denominator, this catalog size, in order to increase the likelihood of finding something relevant. Thank you very much, and I'm happy to take questions.
That was a presentation by Rhonda Textor, Head of Data Science at TrueFit, on TrueFit's approach to product recommendations and extracting information that helps them make recommendations that are more relevant to shoppers, leading to better shopping experiences and fewer size-related product returns. If you enjoyed that presentation, make sure to follow us on YouTube below.